Okay, today we're going to look at something called proof by induction. Now, what I'm going to ask you all to do is to come on a bit of a journey with me. And we're going to look at the process of applying the proof, look at the mechanics of the proof, and then reflect on understanding later. So the key part of today's work is, do you understand at the end of this session the process that you have to work through in order to prove something by induction? And I'm hoping the answer is, if you put enough effort in, yes. But before we embark on this journey, I'm going to give you a bit of a background to what induction actually is. And the best way to describe this is to imagine when you were a kid that you would line up dominoes, and you would stand them up like human beings on their small end. And what you'd eventually do is, the game was that you would topple the first one, and it would hit the second one, and it would topple that one, and it would topple the next one, and eventually all the dominoes would topple to the ground. Now, the inductive process is actually using this principle, except the main part of the proof is, instead of having all the dominoes, you actually go to a place in, just for the sake of argument, it's not a particularly good analogy, but I'm going to go with it anyway, a place in the middle. And you make the effort to topple that domino, and you show that it hits this one and all the rest topple after it. Now, I'm going to leave it there for now, but I want you to have that in your mind's eye as we pursue this particular activity. So here we go. We're going to do a proof by induction. Now, when we're doing a proof by induction, you need to know something. This is a question which allows you to comfortably get a set of marks, even if you don't completely understand it, and even if you don't finish the proof. And most people are guaranteed 10 out of 15 marks by learning key points of the techniques. We can't memorize how to do it. You have to learn key techniques. And if you learn those key techniques and commentaries, you will be guaranteed 10 to 12 marks out of 15. If you're chasing down the H2 and the H1, you have to be able to finish them. So let's get started. So the first thing is, when we say that n belongs to the set of natural numbers, what do we mean? Well, we mean that n can equal 1 or 2 or 3 or ... going on forever. So that's important to establish that. Secondly, you might get this particular question in two formats. You might get it in its summation format, which is top right-hand side of the screen, and it's written up here, or you might get it written in its non-summation format, which is written down here. So if you are given it in its summation format, then you have to do what we did last lesson and actually substitute for r equals 1, r equals 2, until you generate the left-hand side of this equation that we've got above here. Now, let's look at the proof. First of all, there are 4 steps to the inductive process, and you get marks for each step. And step 1 is the title that you have to employ, and you have to learn this language. And what it says here is show true for n equals, now you need to be careful, because in this example, n is equal to 1. But in actual fact, for the inductive process, it is the smallest value of n that they give you. Now, the smallest value of n here that they give me is n equals 1. But don't get into that habit of always assuming it's n equals 1. It could be 2, could be 3, could be 4. It depends on the question. But for this particular question, is we have to show it's true for n equals 1. Now, what does that mean going back to the dominoes? Well, what you're showing is that the first domino can topple. Do you understand? So by showing step 1, showing it's true for n equals 1, you're showing that the first domino can actually topple. Because if you can't topple the first domino, will all the rest topple? No. So we need to show that the first domino topples. So if we're going to show it for n equals 1, we look at this summation symbol up here. What does it mean? R equals 1. And what's n equal to? Well, n is equal to 1. So what does that mean for? It means that all you've got is 4 lots of 1. All you're looking at on the left-hand side is the first term. You're looking at 4. So step 1, show true for n equals 1. So on the left-hand side, if n is equal to 1, I'm only using one of the terms from my summation, and it's the first term, and the answer is 4, quite obviously. Now, on the right-hand side, what have I got? Well, I've got a formula, and the formula is 2n on n plus 1. And now I'm going to substitute my n equals 1 into the right-hand side. So it's going to be 2 lots of 1. Well, you just do that in your head. 2 lots of 1 is 2. And what's 1 plus 1? Well, you do that in your head. What's 1 plus 1? 2. So what is the answer? 4. So what can I now see? Does the left-hand side equal the right-hand side? Yes, it does. And therefore, left-hand side equals right-hand side, therefore shown true. So have I established it's true for step 1? Yes, I have. What does that now mean? It means I've got 5 marks, if I'm being crude about it. Now, step 2, the next stage in the inductive process. Now, for step 2, normally I actually would do step 2 up over here. Now, since I've already used that space for that item there, I'm going to leave it there for now because we might need it for later on. So I'm going to do step 2 here. Now, step 2, you learn to write the title step 2, you learn to underline it, and you need to learn this key phrase. Assume true for n equals k. So you've got to learn that phrase. Assume true for n equals k. Now, do you remember I talked to you about the domino in the middle? This is the domino in the middle, mathematically. So assume true for n equals k. So therefore, what am I assuming true? Now, this is the bit that people find it difficult to understand. So I'm looking at my left-hand side. So what am I assuming true? I'm assuming true that this expression here is true for n equals k, which means I replace the n with the letter k. Therefore, 4 plus 8 plus 12 plus ... plus, and then I replace the n with a k, and then I replace the n with the k on the other side. And I write next to it, is assumed true. Now you're going to say to me, hang on a minute, how can you try and prove something? That's what you're trying to prove. And all of a sudden, you're turning around to me and say, now you're saying assume it's true. Well, you have to hold on. You have to actually just take stock for a moment. Don't get caught up in that. Learn the process. I'll explain to you the thinking behind it afterwards. Okay? It'll become clear. You have to trust me. By the way, that's the end of step 2. So now you are going on to step 3. The language of what you write after the colon is really important. So, need to show true for n equals k plus 1 using step 2 and possibly step 1. Now I've put that in red because for the vast majority of times you don't need step 1 to help you solve this problem. But on the rare occasion that you do, I suggest you always put it in, and then that way you won't forget not to use it when the time comes. Now, what are we going to do now? We need to show it's true for n equals k plus 1. We need to show that the domino can topple in the next position, but only if we use the domino before it. Do you understand? So how do we make this domino topple? We're using the one before it. Remember what I said to you at the beginning of the video? So we're looking at the middle position. So what does it mean I need to show true for n equals k plus 1? Well, I'm going to write it now. Therefore, need to show. Now I'm going back up to here. 4 plus 8 plus 12 plus dot 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 plus 4. You need to get your head around this. This was the one before, 4k, plus 4 on k plus 1 is equal to 2, open bracket, what is n equal to? K plus 1. What is n equal to here? Well, it's k plus 1. Well, what's k plus 1 plus 1? Well, it's k plus 2. Now, if you're worried about making a mistake, then you can use this area up here to do some working out. Now, let's just quickly explore what I just did. I said I wanted to need to show it's true for when a is equal to k plus 1. When n is equal to k plus 1. So let's just see what this means. It means, first of all, I put a 1 in. So it's 4 on 1. And then I put a 2 in. So it's 4 on 2. And then I put a 3 in, and so on, and so on, and so on. And then I put a k in. And then finally, because I have to go all the way up to n equals k plus 1, I put the k plus 1 in. Now, why did I put the k in? Because I hope you read the statement above. It says, need to show true for n equals k plus 1 using step 2. So I had to include on the left-hand side the step 2. And I just did one more bit to it. Okay, so need to show is true. I need to show that bloody blah, 4 plus 8 plus 12 plus dot 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 plus 4 on k plus 4 on k plus 1 equals 2 bracket k plus 1 bracket k plus 2 is true. So what I'm going to do now is I'm going to undertake that proof. And when you're undertaking a proof of this nature, you start off with the left-hand side and you work slowly to the right-hand side. And if you can't get all the way to the right-hand side, then you start at the right-hand side and work your way back and hopefully meet in the middle. So there's my first line of my proof. I'm focusing on the left-hand side. Now this is the clever bit, because if you read your title, it says, need to show true for n equals k plus 1 using step 2. Well, let's take one hard look at step 2. Isn't this step 2? Yes, it is. Can you not see that step 2 is here? And what do we know about this? We're assuming it's equal to this. So we are actually saying that...
Can a student while visiting in secondary Spanish class just call up and ask for a quick question to examine student?
Okay. I'm going to do this. Right, so we've got the left-hand side is equal to 4 plus 8 plus 12 plus other, and now we have to go back and read the statement from step 3. We're going to be using step 2 in order to prove it. So when we're using step 2, we have to go and use the information that we've assumed true in step 2. So, did everyone spot that this part here is in actual fact, quite simply, step 2? And step 2 quite clearly states that this bit here is equal to this bit. This is assumed true. So we can now write down here that this yellow bit is 2k on k plus 1 plus 4 on k plus 1. And here we can quite simply write using step 2. Now, we have to work to the right-hand side. Now, at the end of the day, there's no easy way of doing this. You could expand all the left-hand side out, expand all the right-hand side out, and show that they're equal to each other. Or you can be a bit more flash and factorize it. So if I'm factorizing this, it's actually a lot easier, because I hope you spot that there is a common factor of 2. So I'm taking out 2 as a common factor. I also hope you spot that k plus 1 is also a common factor. So I take out k plus 1 as a common factor. And if I take out k plus 1 and 2 as a common factor, I'm left with k. And if I take out k plus 1 as a common factor from here, it's all gone. If I take out a 2 from the 4, I'm left with a plus 2. Ah, well that's handy, because what's it equal to? Well, it's actually equal to the right-hand side. So I can now write down that this is equal to the right-hand side, therefore shown true. So step 3 is now complete. Now what I can do is I now move on to step 4. Now all you've got to write down for step 4 is that proof follows by induction. And you've got the full marks. So what does it mean? It means this. If you assume that domino does topple, I've just proved that if that one does topple, it topples the next one. And what does that mean? It means they all fall down afterwards. But what did I do in step 1? What did I do in step 1? What was really important about step 1? Did I not show that it toppled immediately? And what I've now proved in step 3 And step 2 is if the first one topples, it will make the second one topple. And if the second one topples, what will it then do? It will topple the next one. And if that one topples, what will it do? It will topple the next one. And that's why induction works. Let's go on to the next example. Okay, it's a summation problem again. This is the second and last example today, and then you're going to be getting questions 1, 7 and 12 to do, and that's all you're going to be doing. And you need to do some peer assessment on this to make sure you're getting it right. So here we go. We're going to do a proof by induction that the equation above, the left-hand side, equals the right-hand side. We've been told in the question that n is belonging to the set of natural numbers. N belongs to the set of natural numbers. And that set of natural numbers is 1, 2, 3, ... going on forever. So that informs us for step 1 that we need to show true, or show true, doesn't matter what language you use, show true for the smallest value of n, which in this case is n is equal to 1. When you've got n equals 1, you are only referring to the first item in a sequence. If you've got n equals 2, you will be referring to the first 2 items in the sequence. If you've got n equals 3, you will be referring to the first 3 items in a sequence. And it's important that you remember that. So what we're going to do here is, because it's n equals 1, we are only going to be making reference to the first term in the sequence. So left-hand side, when n equals 1, is just making reference to the first term. And the left-hand side, therefore, is equal to 7. On the right-hand side, we've got 7 divided by 6 multiplied by 7 to the n minus 1. And we've been told that n is equal to 1, so therefore it now becomes 7 to the power of 1. Well, 7 to the power of 1 is quite simply 7. 7 take 1 is going to be equal to 6. The 6 and the 6 cancel, leaving us with 7. Therefore, left-hand side is equal to the right-hand side, therefore shown true. So step 1 is now finished. So what we're going to do now is we're going to work on step 2. And we work on step 2. We're going to go to this empty space up here on the right-hand side. And we're going to put a title in here which quite clearly states step 2. And you have to learn this expression. Assume true for n equals k. Therefore, we assume the following statement is true. And what now? We're doing it for n equals k, which means we replace the n with a k. So therefore we're assuming that 7 plus 7 squared plus 7 cubed plus ... plus 7 to the power of k, because we replace the n with a k, is equal to 7 over 6 on replace the n with the k and then put in the minus 1. We're assuming that is true. We're assuming that is true. That's the end of step 2. That's finished. We now are going to be moving on to step 3. Now, using this setting out technique, we do get space for working out if we need it, and I'll demonstrate that to you in a minute. Now you've passed the question. So this is rote learning, to be totally honest with you. Step 3, squeeze it in here. Step 3, need to show true for n equals k plus 1, comma, using step 2. You have to use step 2 and possibly step 1, which I'll be honest with you, in this particular example, you don't need to. But step 3, you need to show true for n equals k plus 1. Now, summation for series. What does it mean for n equals k plus 1? It means you've got to have k plus 1 items added together. So you've got all of this. Therefore, I've got 7 plus 7 squared plus 7 cubed plus, so you've got to learn to copy down the left-hand side of step 2 plus 7 to the power of k, and then add on when n is equal to k plus 1. So add on 7 to the power of k plus 1, and is equal to 7 over 6, open bracket, on 7 to the power of k plus 1 minus 1. Need to show true for n equals k plus 1 using step 2. Therefore, 7 plus blah, 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 blah equals blah, 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 blah needs to be shown to be true. What's the process for doing this? Well, I write the word proof over here. I write down left-hand side and write down 7 plus 7 squared plus 7 cubed plus dot, dot, dot plus 7 to the power of k plus 7 to the power of k plus 1. And what I'm trying to do is I'm trying to manipulate it to show that it's equal to what the right-hand side is, and what the right-hand side is 7 over 6, open bracket, 7 to the power of k plus 1 minus 1. But I have to use step 2. So what is step 2? This is step 2. So what does that mean? It means that this part here, which is the step 2 part, can now be replaced by this. It can be now replaced by 7, open bracket, 7 to the power of k minus 1, which we've assumed to be true in step 2. So down here, I can now write all the green bit is 7 over 6 on, open bracket, 7 to the power of k minus 1, close bracket, plus 7 to the power of k plus 1. Now there's a very real danger that you will struggle to actually get this right. So now what you've got to do is you've got to play the game. And the game is that you may get to this point in time in an exam and can't finish. So in order to get extra marks, you go way down the bottom and you write in step 4, proof follows by induction, so that you demonstrate to the examiner that you understand the 4 stages of induction. Now, the next thing is you've got to learn a few little tricks. And really, there's so many different ways of doing this. It depends on what you spot on any given day. But usually, we're looking at a factorization method. Okay? You're looking at, and I'm not saying the method I'm about to do is the fastest or the slickest, whatever, but it's the one I see today. And I need to factorize. And in order to factorize, I'm going to make my life look a little bit sort of, in explaining it to you, try and make this look just slightly simpler to spot a factorization. So I'm going to write this as 7 on 7 to the power of k, where I've used the laws of indices in reverse. That when you are adding indices together, it comes from a product of bases. And the reason why I did that is because I know the method for solving this problem is based on factorization. So I wanted to get 7 on its own. And why did I want that? Because I've looked over here, and what do I see outside a bracket? A 7 on its own. So I'm using the answer on the right-hand side to help me work through this. Now, there's one other very tiny bit of a problem. And the bit of the problem I've got is I'm also meant to be able to factorize out a divide by 6. I've already identified I can factor, but I've got a slight problem. I've only got to divide by 6 on one part of my question. Is that not right? So this is where a little bit of jiggery-pokery comes in. Guess what I'm going to do? I'm going to put a 6 on the bottom. But if I put a 6 on the bottom, I need to put a 6 on the top. Why did I put that 6 on the bottom? Well, because according to the right-hand side, I need to factorize out a 7 over 6. Do I have a 7 over 6 to factorize out? And the answer is yes, I do. So now I can move my problem on. By the way, I'm just rubbing that little bit out because you only put that in when you can't go any further. Try and go as far as you can before you put that last line in. Now, what have I got here? Well, I have got a factor. What is the factor? It's 7 over 6. Open up my bracket. If I take out the 7 over 6, what am I left behind? In the first instance is 7k, 7 to the power of k minus 1. What am I left with over here? I'm left with a plus 6 lots of 7k. I've just moved that 6 to the front of the 7k. Now, it's very simple. If I've got 1 lot of 7k plus 6 lots of 7k, how many lots of 7k do I have? And the answer is I have 7 lots of 7 to the power of k. I didn't say to the power of k, bold. So 7 over 6, I have got 1 lot of 7 to the k plus 6 lots of 7 to the power of k, and therefore I've got 7 lots of 7 to the power of k minus 1, close bracket. But now, using the law of indices in the usual way, what do you do with powers? Well, you add them together. Now, it's quite obvious that I've run out of space here, so I'll uncharacteristically go off to the side. And so now I've got, adding the powers together, I get k plus 1 as a power minus 1. And of course, what you can see from above, this is identical to the right-hand side. Therefore, shown true. I have shown it to be true. What's written on the line below this is step 4, proof follows by induction, and that's the end of the example.